Now that I have the force of gravity, I think it's a good idea to go ahead and calculate that normal force. Now, think about this problem, because we haven't written this down yet, but think about it. Vertically, what is the acceleration of this object? Is this truck braking the surface that it's on? And hopefully your answer is, in fact, no. So we know that our acceleration is 0. Okay? We know that acceleration is 0, which actually gives us another key point of information. Our F net vertically has got to be 0 as well. And I know what you're thinking. Mr. Rapid tells us the acceleration is negative 4.5 meters per second squared right there. Well, guess what? That's actually just for the horizontal. These two things don't mix. Remember when we talked about the independence of dimensions when we were talking about projectiles? That's exactly the same case here as well. Okay, so we need to have that to get our net force vertically. And we need that net force vertically to solve for our normal force. We don't have to show this calculation. That's a really easy one. You can if you want. That's using Newton's second law. You can if you want, but you don't need to. What you are going to want to do afterwards to solve for that normal force is use the sum of our forces. F net is equal to, now remember we're doing vertical only here, so it's the Fn, upwards force, oops, let's write it as up, minus our downwards force, Fg. Okay, so what does this look like? It's Fn minus F, I did it again too. This will be our upwards force minus the downwards force. Okay, Fn minus Fg, right? So I get that from my picture. Now I can go ahead and plug my numbers in there. I have 0 is equal to Fn minus 9,800. I'm going to add the 9,800 over to the other side. And I'm going to see here Fn is equal to 9,800 newtons. This is a step you do need to show me.